So let's go over the chain rule today. I want to go over this really well because it's extremely important. You're going to see a lot of it in Cal 2 and the rest of this course as well. So it starts out with it's basically how to do the derivative of the composition of two functions. So we need to go over what the composition of functions is from algebra so that we can understand the chain rule better. And there's a notation here that really relies on it. So composition of functions, you can have the first thing I want to go over though is how you can describe what this means. F equals f of x. What this is mathematical shorthand for um, f is a function of x. F is a function of x. So it can be written uh, differently. Can be a lot of times you might see like y is f of x, but I want to keep the two letters. I want to keep those the same, and you can. There's no problem. In fact, you might have already seen y equals y of x. It's just shorthand for y as a function of x, which just means that y is some function that's like sine x, or y is x squared plus 3. It just hasn't, the variable is x. It's all the same. All right, so what I want to do is I want to create two functions. So consider f equals f of g, and g is a function of x. So f is a function of g, and g is in turn a function of x. All right, so what this is saying is that there's a box of x's here. G does something to them, and then f does something to those. So you could have something like g, let's say g of x is 4x plus 5, and then f of g is x cubed. So there's a little x in here. Let me do this in a different color. There's a little x in here. And g will take that and make it into 4x plus 5. F will take that and it'll cube it. So 4x plus 5 quantity cubed, like that. All right, so the question is, how do you take the derivative of that? So if you have y equals 4x plus 5 quantity cubed, what is the derivative? Okay, so what is that? So it turns out that in order to take the derivative, you have to see what the main function is, that would be f, and the inner function is, that would be g, or the outer function and the inner function if you want. So if you have the situation where f is a function of g and g is a function of x, you have to go through g to take the derivative of f with respect to x. So the derivative of f with respect to x, I have to go through g to get there. So that'll be df dg. So I take the derivative of f with respect to g. So I'm taking the derivative of f with respect to g. And then I multiply that times the derivative of g with respect to x. So let's look at a problem. Let's look at that problem that was down there. This one here. So you have let's just write about it. F of g is 4x plus 5 is g cubed, and then g of x is 4x plus 5. So derivative of f with respect to x is derivative of f with respect to g. You do that first, and then times derivative of g with respect to x. You can almost think of it as like these two canceling. That's not what's happening, but if that helps you remember it, that's okay. Derivative of f with respect to g, that's just g cubed. So that's 3g squared. So, and then derivative of g with respect to x, g is 4x plus 5. So that would be 4. So you would get, out of this, you'd get 12g squared. But then g is this 4x plus 5, so you can just write that in there. 12 times 4x plus 5, quantity squared, and there's your answer. All right, so let's try another one. Let's say, suppose, so example, suppose y is sine of x squared minus 3x. So I want to find y prime. So what's y prime? Well, the outer function f would be f of g is sine of g, and then the inner function g of x would be the x squared minus 3x. Because normally what you would have is just sine, good old sine x. So the main function is this, the f1. All right. So the derivative of f with respect to x, you go through g first. So derivative of f with respect to g would be cosine g. I'm just looking at this again. And then the derivative of g with respect to x would be 2x minus 3. Let's put that in parentheses. And then you just put what g is. Cosine of x squared minus 3x times 2x minus 3. And I want to make sure that the reader knows that it's not cosine of all of this. It's just cosine of the first one times that second one. So this would be 2x minus 3 times cosine of x squared minus 3x, like that. And there's the answer. So you get the hang of this after a while. There is one rule, the power rule, that really comes in handy if you see it. Here's a main, let's just say the general power rule. Power rule says this. So suppose u is a function of x, then if you have u to the n power, right, parentheses, if you have u to the n power and you want to take the derivative of that, well, let me write d dx. No, I'll write derivative. You want to take the derivative of that, it's n times u, n minus 1, times u prime of x, like that. I think I will write d dx like this. So I'm going to find the derivative with respect to x. If I write u to the n prime, you might just stop right here at n times u to the n minus 1, because it's not, this prime isn't saying I want to take the derivative with respect to x. It could just mean derivative with respect to u. So to lessen the confusion, I write d dx. So if I give you something like this here, then it's implied that u is already a function of x. Okay, so let's do an example of this. Suppose you have something like, let me do it in black. Y is, what do we have? X to the 4th minus 3x squared plus 1, and then that would be to the 5th power. So then y prime would be, you take the 5, pull it down in front, you rewrite the inside, 3x squared plus 1 here, and then you decrease it by 1, just like you would normally. See, if it were u to the 5th, the derivative would be 4u to the 5u to the 4th. 5u to the 4th. So 5u to the 4th, like that. Now you take the derivative of the inside. So now when you take the derivative of the inside, you get 4x cubed minus 6x. There's your answer. Another way you could do this is multiply that out 5 times. You FOIL that out 5 times and then take the derivative of that, but that would take forever. So it's obviously not the way to go. So that's the chain rule for that. If you look there very carefully, there's other problems that are similar. You just may not recognize it. If you have y equals sine to the 6th of like x squared minus 3, then this can also be written as sine of x squared minus 3 all to the 6th power. So you can write, like recall in trig, this comes straight from trig. This is just another way to write it. So if I had sine x to the n power, we wrote that as sine n to the sine to the n of x. So in other words, cosine, you could do cosine too. Cosine x squared is cosine squared of x. All right. Now, there's a danger in doing this though, because you got to be careful with inverse functions. It's not the same thing. So if you have sine x to the -1 power, this is not sine -1x. This is inverse. This is arc sine of x. And this here is 1 over sine x, which is cosecant of x. And these are not equal at all. All right, so that's just an aside. So let's go back to the previous problem here. And so the way you would do this, you pull the 6 down in front, rewrite the sine business, sine of x squared minus 3 to the 5th power. And now you multiply by the derivative of the polynomial. Oops. You take the derivative of sine, so now it'll be cosine of x squared minus 3. And now this itself is a chain rule, so now that's times 2x. So this ends up being 12x, that's sine of x squared minus 3 to the 5th power times the cosine of x squared minus 3. There we go. It's kind of a hard problem. There's chain rule twice. Let's try another one. Let's maybe try tangent. So example, let's try tangent. So let's say y is, let's say tangent cubed x. Let's take tangent cubed of sine of x. How about that? So this will be y prime will be 3 tangent of sine of x. And then you take the derivative of the inside. Well, now, oh, hang on, it's now tangent squared. It's 3 tangent squared of sine x times the derivative times tangent. So that would be secant squared of sine x. And now you take the derivative of sine x, which is cosine x. And that's pretty much it. That's the answer. You really can't simplify that any further. Now, if you don't understand what I did, all you have to do is rewrite y as tangent of sine x quantity cubed, and now use the general power rule. So if you do y prime, you do 3 tangent of sine x, and then you raise that, you take that 3 down by 1, that's to the 2nd power now, and now we're going to take the derivative of the inside. Derivative of tangent is secant squared of sine x. And now I take the derivative of the inside of that, which would be cosine of x, and there you go. That's how we do it. All right, so I want to write some general facts down that will make this a lot easier in general. And I noticed that my Cal 2 students really benefit from this. If you have a sine of u, and you want to take the derivative, now all these derivatives are with respect to x. This is u prime cosine of u. If you have cosine of u, so here u is a function of x in all of them. Then this would be negative u prime sine of u. And then tangent of u prime would be u prime secant squared of u. And then you have all the rest for secant as well. Secant of u prime is u prime secant u tangent of u. All right, so let's look at let's see from the notes what some examples might be that might be kind of difficult for you to handle, maybe. I don't know. E to the x, that's a good one. Let's try e to the x squared minus x, that one. So let's say we have y equals e to the x squared minus x. So the outer function is e to the x, and the inner function is that x squared minus x. So in other words, f is equal to f the e to the x business, and then g would be equal to that x squared minus x. So the derivative of y with respect to x, you do, the derivative of the e is just e to the x squared minus x. And now you take the derivative of the derivative of e to the x is e to the x. So I'll show you in a second. Let me just finish this and I'll show you what I've just done. So in general, e to the u prime, this is u as a function of x, is u prime times e to the u. If I write this in terms of f's and g's, this is what it looks like. You'll have f of g is e to the g, and then g of x is x squared minus x. So I'm taking the original function and I'm just writing it in terms of f's and g's. So now when we try to find df dx, we're going to write df dg times gg dx. So df dg is just e to the g. E to the x, the derivative is e to the x. So e to the g, the derivative is e to the g. And now, so that's this piece. And now derivative of g with respect to x, pull this down, that'll be 2x minus 1. And so just re-plug in g, so this will be e to the x squared minus x times 2x minus 1. And a lot of times I write it as 2x minus 1 e to the x squared minus x. Now, one problem that does come up quite a bit is root problems. Do we have one of those in the examples? Yeah, this one right here is a good one. 1 over the cube root of x squared minus 1. That's going to be the chain rule twice. So let's try it here. Y is 1 over the cube root of x squared minus 1. So what I want to do is I want to rewrite this just like we did with powers as the root as something to a power. So it's going to be, first of all, this is 1 over x squared minus 1 to the 1/3 power, because the square root of x, the cube root of x, is this x to the 1. This will be x to the 1/3 power. And now, when I have 1 over something to a power, that's actually that thing, whatever it is, x squared minus 1 to the negative power like that. So I rewrite y like that. Now, well, I want to take the derivative, so I write y prime. So this is going to be the derivative with respect to x. So y prime is, I'm going to use I'm taking it of this. So I'm going to use the general power rule, bring the 1/3 down. So it's negative 1/3, and then rewrite the inside, decrease it by 1. Negative 1/3 minus 1 is negative 4/3. And now take the derivative of the inside. And there you go. Now you want to write this so that there's no fractional or negative powers. So this is, let's make this negative 2x over 3 times, and then I'm going to write this as x squared minus 1 to the 4/3 first. And now it's inside over outside. So if you have if you have x, let's say y to the a over b, this is the bth root of x of y to the a. So this will be negative 2x over 3. Now 1 over the cubed root of x squared minus 1 to the 4th power. Now technically you can pull out an x squared minus 1 out of that. I'm not going to worry about it right now. So let's just write it as negative 2x over 3 cubed root of x squared minus 1 to the 4th power. And there you have it. There are a lot of really cool applications in the chain rule. Let's see, before I get to those, is there anything? Now you can, second derivative too you can do. This is a neat function here. This is used in engineering, particularly sound engineering, electrical engineering. So I invite you to do that one. Find all points on the graph of the function f of x equals 2 sine x. This one's a good one too. Tell you what, I'm going to graph that, and then I'll take the derivative, and we'll see all points at which the tangent line is horizontal. So let me pause the video and we'll come right back. Okay, so here we are. So I invite you to pause the video and check out what I've done here. We're graphing this function right there. So it looks like the horizontal tangent lines are going to be somewhere between 1 and 2 and somewhere between 4 and 5. So I'm going to take the derivative of this. So it's y equals 2 sine of x plus sine squared of x. So that sine squared of x, that can be written as sine of x. Let me rewrite this. Can be written as sine of x quantity squared, like this. So when we take the derivative, we get 2 cosine x plus 2 sine x to the 1 power times the derivative of the inside, that's cosine x. All right, now we have to find out where this thing is horizontal. So we set the one side to 0, and it looks like I can pull out a 2 and a cosine x, and I get 1 plus sine x. So we get 2 cosine x equals 0, so that would be cosine of x equals 0. So that would be, unit circle gives us pi over 2 and 3 pi over 2. Then I do 1 plus sine of x equals 0. So I get sine of x equals -1. So x would have to be 3 pi over 2 again. So, yeah, that's right. So pi over 2 is like 1.57. And 3 pi over 2, when you do it on a calculator. So let me pull my calculator out and we'll figure this out. It's going to be less than 6. So 3 times pi divided by 2 is 4.7. That's 4.7. And so if we look at where we're at here, kind of looks like, yeah, sure, probably 4.7. It's maybe right there, and that's where the tangent line is horizontal. And the other one was 1.57. Yeah, sure, that's where tangent line is horizontal as well. All right. It's very important that you understand how to solve trig equations. Very, very important. This comes up over and over and over. So please get good at it. All right, so that's the chain rule.